Welcome back to 3D Decode. Today we're going deep into one of the most important control strategies in rotating equipment, anti-surge control, or ASC for centrifugal compressors. Surge is a violent flow reversal that can crack seals, bend shafts, and even shut down entire plants. As a designer, your job is simple. Keep the compressor operating to the right of the surge line at all times. Let's break this down. The compressor map, what you control against. A compressor map has x-axis, corrected flow, y-axis, corrected head or pressure ratio, surge line, the left-hand boundary where flow becomes unstable, stonewall or choke line, far right limit, not today's focus, speed lines, a family of curves for different compressor speeds, control line, a margin, typically 10-15% to the right of surge line. ASC keeps the operating point right of this control line. Always use the vendor's corrected formulas for flow, head, and speed. They define the reference conditions and their math wins. Signals and hardware. What makes or breaks ASC? Instrumentation is key. Flow transmitter, FT. Suction flow, corrected for pressure and temperature. Pressure transmitters, PT. Suction and discharge to calculate head. Temperature transmitters, TT. For inlet corrections. Key phaser, optional, for speed correction and advanced diagnostics. The recycle valve is the heart of the system. Fail-open pneumatic control valve. Equal percentage trim, low backlash, low hysteresis. High CV, sized for worst-case conditions. Stroking time 1 to 2 seconds. Critical services may need Tox 1 second. Accessories, smart positioner, volume boosters, quick exhaust, lockup relay, and clean instrument air. Routing, short, low-loss piping, no sharp elbows. If recycle alone can't unload fast enough, some plants also use blow-off to flare. Building the control strategy. A. Distance to surge algorithm. Compute distance equals operating point control line value. Primary PID regulates the recycle valve to keep distance pos 0. High gain, fast integral near the line, anti-reset wind up. Filter signals lightly to reduce noise without adding lag. B. Selectors and overrides. Low select between ASC demand and operator set point. Force valve open on startup, stop, settle out. Permissives. LOS pressure, seal gas DP, valve health OK. C. Surge detection and recovery. Detect patterns, sharp delta P rise, flow collapse, vibration spike, discharge T-swing. On detection, command valve fully open, hold, alarm, and escalate per cause and effect if repeated. Sizing the recycle valve. To size the valve, define worst-case scenario. Startup at settle-out pressure, low suction, max speed, heavy gas. Compute required flow to shift point right of control line quickly. Check delta P across valve and piping. Calculate CV. Keep normal operation in 30 to 80% valve travel. Pick actuator with torque margin, boosters for fast stroking. Test stroke time and failsafe during fat sat. Startup and shutdown sequences. Startup, recycle valve open, permissive satisfied. Spin up, stabilize flow, ASC trims valve as compressor loads. Normal stop, recycle open, unload, then stop driver. Trip blackout, loss of air or ESD, valve fails open, compressor coasts safely with maximum unloading. Tuning tips, equal percentage trim improves resolution. Use proportional gain higher near surge line. Limit integral far away. Add feed forward from speed or guide vanes if available. Light filters, 0.2 to 0.5s on FTPT signals. Common failure modes and fixes. Valve too small, slow. Respect CV, bigger actuator, more boosters. Wrong PT corrections, align with vendor's formulas. Sensor lag noise, relocate taps, clean impulse lines, tune filters. Bad air quality, dryers and filters to avoid sticky valves. Piping losses, increase line size, avoid sharp turns. Mini example conceptual. Vendor surge line, HC equals A plus BQC. Control line, HCTRL equals HC 1 dis margin, where margin is 12%. Distance equals HMIAS eknia HCTRL QMIAS. PID drives recycle valve to keep distance to 0. Always use the vendor's exact formulas. Mini quiz. 1. Why must the recycle valve fail open? 2. What is the control line and why use it instead of the surge line? 3. Name 2 signals essential for distance to surge. 4. List 2 hardware features that make a valve fast. 5. What's your first action on surge detection? Practical tasks, hands-on. ASC loop narrative. Document inputs, distance calc, PID logic, overrides, and surge detection. Valve spec sheet. Include CV at worst case, stroke time, trim actuator, fail open, accessories. P&ID markup. Draw recycle path with FTPT TT taps, boosters, positioner, and FO symbol. Interview Q&A. How do you ensure ASC works if the flow transmitter fails? Use backup head-only control, hold last strategy, alarm, and bias valve open. Y equal % trim for recycle valves. Gives finer resolution at low openings and near linear flow versus signal. What's settle-out pressure, and why is it important? System equilibrium pressure after trip. Valve must pass enough flow at this delta P to prevent surge during coast down. Q. How do you select surge margin? Project vendor spec, typically 10 to 15% based on uncertainties and dynamics. When add blow-off to flare. A. If recycle path is insufficient or safe disposal of process gas is required. And that's a complete deep dive into anti-surge control, ASC, one of the most important protection systems in centrifugal compressors. If this video helped you, don't forget to like, share, and subscribe to 3D Decode for more deep dive engineering content. See you in the next session.